Now, solving log equations, before we get this one, here is the most simple log equation that we could solve. A log equation is where the x is inside of the logarithm. Looking at this, can you tell me what x is just by looking? I think should be close. It's 8. Okay? Now, what does a log do? A log solves for an exponent. So this is some exponent. And when we look at it this way, when we read a log, log 2 of x, we sometimes think 2 to what exponent is x? Well, we know the exponent is 3. So 2 to the 3 is x. Well, 2 cubed is 8, so maybe you can just see that the answer is 8. Although it's not easy to see, okay? Okay? It's not easy to see like this is easy to see, right? You can look at that and say x is equal to 4 right away. It just makes sense to you. This doesn't quite make sense to you as much because you haven't worked with it as long. So what do we do with a log equation to make it easier to see? We change it. We use the definition. We use the definition and say, I know that 2 is the base, I know that 3 is the exponent, and I know that x is the answer. And now this is much easier to see that the answer to x is that x is 8. So the key to solving for x in a log is being able to use the definition. And then it's really easy to see 2 cubed equals x, so x is 8. The only way you can use the definition is if you have a single log, which in this case we did. We started with that. That's what made this one so easy. We started with a single log, then we could use the definition, and then we could solve for x. So as far as our steps go for solving a log equation, the very first thing that you're going to do, number one, is combine your logs to a single log. Because if you can combine it to a single log, then you can use the definition and change to exponential. Woo. Wow, I don't know what word I was trying to spell. I can't spell anything right now. Exponential form. Beautiful. And then it will be easy. It will turn into an equation that you can use your previous math skills to solve for x. So we're going to combine our logs to a single log. We're going to use the definition to change it to exponential form. It will then be easy to solve for x. The fourth thing that we'll have to do is in this process, sometimes you get an answer which appears to be right, but in reality isn't right. So that's called an extraneous root, where it appears to be right, but it isn't right. And the way that we check for extraneous roots is you plug it back in. You don't actually have to evaluate anything, but you just have to make sure that there are no logs of negative numbers. Because a logarithm, if you think about its graph, a logarithm's domain is just when x is bigger than 0. So anytime you take the logarithm of a negative number, it's outside of its domain and it's not possible. It's like trying to take a square root of a negative number. Try it on your calculator. Log -5. Your calculator is going to say error domain. So these are our steps. We combine to a single logarithm, use the definition to change it to exponential form, solve for x. There we go. And then finally, we have to check for extraneous roots. And we do that just by plugging our answers back into our original equation and make sure we're not taking the log of a negative number. So I'm going to save these instructions up here so you still can read them. And we can look back at them at any time. So here's our first equation. Step 1. We need a single log in order to use our definition. How many logs do we have? 2. Can you combine them? Well, our log laws say that if you're adding 2 logs, that's the same as multiplying inside of our log. It's still equal to 4. I mean, you could have simplified this. This is the same as 9x squared equal to 4. Good. It's a single logarithm. We wanted that single logarithm because we can now change it to an exponential form. And our exponential form will be something that we can do more math with. Right here, you're looking at this, and you're like, I can't quite visualize what's happening. There's still some math to be done. Even though I know the exponent is 4, the base is 3, the answer is 9x squared, I can't necessarily see what x has to be. But if I change to exponential form using the definition, and this is the hardest thing to remember in these equations. So ask yourself, how are you going to remember the steps for solving a logarithm? And the most important step right here is once you've got a single logarithm, to change it to exponential form. Because now it's an x squared equation. Can you do 3 to the 4? It's on your powers chart. What's it equal to? 81. What would you do if you were solving this equation? Divide by 9, so you get 9 equals x squared. What would you do if you had x squared equals 9? You would square root, and you would get plus or minus 3. Excellent. Once you've gotten plus or minus 3, in logs you have to check. You have to go back to your original equation and plug in the number. You don't have to evaluate it to find out if it works. All we're going to do is check if it's a possibility. So when I check positive 3, I plug in positive 3. I have log 3 of 27. Is 27 a positive number? Good. We don't worry about it. Here I have log 3 of 3. Is 3 a positive number? Good. So we go down to this one and we say, yes, I'm happy with that one because I didn't take any logs of negative numbers. I didn't take log of 0. Let's try negative 3. Plug it in the first one. 9 times negative 3 is negative 27. Is negative 27 a negative number? Yeah. We don't have to check anymore. As soon as you get a negative number inside of a log once, put an x through that. Right? Not possible. You need to indicate that you understand that it's not possible. Somehow, xing it out. You can't just, they will not give you full marks if you just circle this one and don't circle that one. They want you to make sure that, you know, you don't have to over-exaggerate it, like have it explode or anything like that. Just a single x through it. NP for not possible is okay. So our only solution to this one is x is equal to 3. So to recap, what did we do? We combined our logs to a single log. We used our definition. Okay. This is the step I'm going to forget. Step 2, once you've got that single log, you'll be like, what do I do next? Because it's such a weird thing to do, to use a definition in the middle of algebra. Use that definition to change to exponential form. Solve for x and check for extraneous. Perfect. So we're going to do example 2 now as well.